Here's another example of, as we were referring to in the previous clip, voters. When pollsters put polls together to predict who's going to vote for which candidate and whatnot, they generally do an exceptional job of polling people that look like the population. And if they didn't, the polls would be considered to be basically worthless. And that they're successful when they're constantly quoted. You'll see, depending on if you watch closely in an election year, Reuters and Zogby and Rasmussen, Quinnipiac, CBS, New York Times, CNN, all of those major polling organizations do a good job at getting it right because they select representative samples. I'll give you an example. In 2004, and I know that's when some of you were very, very young, we had a very close election, as we did in 2000. We had two consecutive extremely close elections. In 2004, the pollsters largely got it right in the last 4 to 6 weeks of the election. It was George W. Bush, the incumbent, versus John Kerry, the challenger. And Bush won by, I think, 1.2 percentage points. And polls consistently showed that, based on 1,000 phone calls, that Bush won by roughly 1 or 1.5 points or 0.8 points or what have you. So they did an excellent job at getting it right. A rare exception to this was 2012. 2012 featured the incumbent President Obama versus Mitt Romney, and Reuters, I believe it was, I better be careful, had it wrong. They actually had Mitt Romney winning the presidency over the incumbent Barack Obama, and Obama won by, I think, 2.4 percentage points, which is a fairly large margin in recent times. So how could they get it wrong? They must have used a skewed sample. They didn't intend to, I'll tell you that, because honestly, it was at least mildly embarrassing that they got that incorrect. So we have a relationship here between a population and a sample. We've got this population of all the individuals of interest. Could be voters, could be males and females, or boys and girls, rural versus urban residents, people that were exposed to a treatment versus people that were not. And we select a sample from that population. The sample are the individuals selected to participate in the research study. Now, we'd like to think that they're representative. And if we can conduct a study that may suggest that boys are outperforming girls or girls are outperforming boys on a particular task at a certain age, I'd like to generalize that to the population. Maybe say, well, at age 6, one gender, if you can simplify down to 2 genders in that example, is outperforming another gender on a particular task. For instance, there's an older piece of research that shows that girls happen to be better at boys at phonemes at an early age. They're better at pronouncing new words because they've mastered phonemes. That's generalized to the entire population of boys and girls based on a sample of what may have been 20 boys and 20 girls. So a variable, characteristic or condition that changes or has different values for different people. That could be names, ethnicity, religions, any kind of personal variable, or a numerical thing like height or blood pressure or weight or body temperature at this moment or heartbeats per minute, etc. All those things are considered to vary, and they can vary by person or vary by entity. The temperature in the continental United States versus Australia. Our seasons are basically reversed. That's a variable. Temperature and humidity are both variables. So in this case, let's say I was talking about the classical Stroop task. In this case, I can measure the Stroop task performance down to the millisecond. So if I had the classic Stroop task, you might have seen this before. And let's see if I've got a slide that refers to it. I do not. That's annoying. In which you name colored words, the color of the colored word. So for instance, the word red printed in red versus the word red printed in green. Well, if you have people name the color of the font, that would be congruent if it's red written in red. And that might take as little as, say, on average, 720 milliseconds. Conversely, if it's red written in green, and the correct answer is green, in that case, that's incongruent. and it takes a little bit longer. So the bottom line is that the Stroop effect particularly is not so important, but the fact that we have a variable there that varies between two conditions, reaction time. And in this case, by the way, the reaction time is measured in milliseconds, which is pretty refined. That takes a computer to do. That's hard to do with a stopwatch or anything like that. So if I can measure that in milliseconds, then in that case, I'll have a very, very fine variable that can reveal a unique psychological process, as the Stroop effect does. If you're not familiar with the Stroop effect, it might be worth a Google. Just Google Stroop effect, Stroop, and you can see the difference in how it would make you perform.